Today we'll be talking about moment distribution method in our structural theory CE311A. By the way, I'm Belgian Delphine Clavicilias, a third year student from USM, a civil engineering section C. We have this problem. Draw the shear moment diagram of the frame shown in the figure using Hardy-Cross method or the moment distribution method, and compare your answer using the approximate analysis. On the left side you can see that is our first problem. That's the problem. And on the right side is the actual frame. It has a vertical length of 15 feet from both floors, and down below it have a horizontal length of 30 feet. On the very top you have the 9k as your load and 18k on the load for the middle. um, Now, um, uh, the two free body diagram on the right side are just a frame subject to MQ1 and a frame subject to MQ2. A free body diagram is drawn to easily understand and solve our given problem, as you can see. Now, would be first you have to find your stiffness factor, in which um, you have the formula of K equals to I over L. Thus, down below the formula is the corresponding stiffness factors of the segment members. The stiffness factor of AC, KBD, and KCE and KDF would be equal to I over 15, considering that the length is 15 and the formula have I on the top. And next is the stiffness factor of KCD and EF is equals to 2I over 30. And having that, pardon me, that should be an I. You would also be having a I because 2 and 30 can be simplified as 1 over 15, thus having I over 15. And for the distribution factor, you have the formula of dF is equals to K over ZK. And that's how we do it. dF, distribution factor of AC, is equals to FB, or dFBD equals to 0. And your distribution factor CE is equals to is equal to the distribution factor of EF equals to, follow the formula. Your K is I over 15 over both the stiffness factor of CE and EF resulting to 15. Just add them both, having 15 over 30, simplifying it to 1/2 or 1 over 2. And the distribution factor of CA is equals to the distribution factor of CD is equal to DFCE. Thus, following the formula, K, the K is 1 over 15 over 3, 1 over 15, because that's just the factors of CA, CD, and CE. Resulting to 15 over 45, and simplifying it will be equal to 1 over 3. Now we will be finding the fixed end method, the FEM, having the formula of 6 EI delta prime sub 1 over 15 squared. This, as you can see on the right side of the PPT, that is the frame subject to MQ1. And I've taken the liberty to just directly solving it. Thus, as you can see on the left side, the fixed end moment of AC is equals to CA. If you're wondering why, because same for the reason is that the units are just swapped or the letters are scrambled, thus having the same result if the corresponding units are just the same. Thus AC and CA have the same fixed end moment equal to 100, and BD and DB also 100. CE and EC is equal to negative 100, and DF FD is equal to negative 100. And moving into MQ2 moments, um, the right side of my PPT on the lower part. The FEM having the same formula, and thus resulting to FEMCE is equal to FEMEC equal to 100. Same reason, because the letters are just scrambled, having the same units, meaning having the same result. And FAMDF, FMFD is equals to 100. Now, we have our table here. For the joint ACEFDB, we have the members of for A, we have the AC and CA. Also for this, the members of the C are CD, CE, EC, and so forth for each joint member EF, FE, FD, DF, DC, DB, and BD. We have the distribution factors. We already got this. For the AC, we have 0. In regards from our last couple of slides, we have 1/3 for the CA, 1/3 for CD, 1/3 for CE, 1/2 for EC, 1/2 for EF, 1/2 for FE, 1/2 for FD, 1/3 for DF, for DC 1/3, DB 1/3, and BD 0. The fixed end moments, we have 100 for AC, 100 for CA, and negative 100. Now let's proceed to C1 on the balance. If you're wondering in any case why we've got 50 here, simply negative 100 would be multiplied to 1/2. Thus, you would be getting 50, and your 50 would cross over to CE. If you're wondering why CE, it would be as because 50 would again be multiplied to 1/2 and cross to CE. And then after that, if you're in a case wondering the balance in C2 on the line of CE, negative 8.3, it would be because your current balance would be multiplied to your fixed end moment. Thus, you would get the answer, then you cross over. If you would be crossing over to the other member, your number, your current balance or your crossover would be multiplied to the DF of the corresponding line of member. Like for example, let's look at the balance in C1 at EF. We have 50 because EF would be times 100 would be times to a half, 1/2. 1/2 just getting 50, and 50 would cross over to FE from EF, and as it crosses over, it would be multiplied to 1/2, thus getting 25, and so on and so forth. You would be getting the same results. Your balance would cross over, and as you cross over, your current balance or your crossover would be multiplied to the DF of the corresponding member. Now, as we continue, we proceed to the summation of moments. First, we would be look at the upper left part. We will be doing the summation of moment E, and all forces acting counterclockwise would be positive. So all forces acting counterclockwise is positive, and the summation of moment E is equal to 0. We have Cx equals to 15. In any case, you're wondering where 15 came from. It would be from the feet or the length plus 85.3. The 85.3 came from the E. 85.3 of DF, of line DF, negative 85.3. That's where it came from, in the line of DF. Thus, you have that result. 85.3 minus 61.75, 73, sorry. That's the value up there, equals to 0. So your answer will be Cx equals to 9.8 K. That's a force going right. And since Cx is equal to dx, therefore dx would be also equal to 9.8 K going to the right. And next is again for the summation of C. All forces acting counterclockwise is positive, and the summation of moment C is equal to 0. So AX times 15, that's the length, plus 97.04. In any case, you're wondering where we get that, we have the line of B, 97.04. You can get it right there, or the line of C, 97.04. You can get it right there. Plus 94.19, acting that it would be from that line is 97.04 plus 94 equals to 0. Thus Cx is equal to 12.75 K going to the left side, and since Ax is equal to Bx, then Bx also have the same result, 12.75 K force going to the left side. And next is all forces going to the right side is positive. Summation of all forces H is equal to 0. That's your QA sub 1 plus 9.8, as you can see it right there, plus 9.8 equals to 0. Thus your QA1 is equal to 19.6K going to the left. And again, for your summation of all forces of H is equal to 0 for the QA2, 19.6 minus 12.75 minus 12.75 is equal to 19.6, because that's the result of QA1. Let's substitute there. You'll be getting the value of 45.1 K going to the right. Let's proceed to the moments of MQ sub 2. Our other table was for the MQ sub 1, and this table is for the MQ sub 2. The process is the same, just keep on cross multiplying, and your current balance, if it cross over, it would be multiplied to the DF of the corresponding member, just like we did with the other table. So just keep on going, because the process is the same, but the results would be not, because it's another group of members. And for this, again, on the upper left side, we have all forces acting counterclockwise is negative, or is positive, I'm sorry, for the summation of all moment E is equal to 0. Then Cx times 15, for this is the length, plus 58.81. That is the 58.81, you got right there for the C, and 52.95 for the E, equal to 0. Thus, Cx is equal to 7.45k, and since Cx is equal to Dx, you would be getting the same result of 7.45k. Then let's proceed to the summation of forces B. All forces going to the right is positive. For QB1, negative 7.5 minus 7.5 is equal to 0. Thus, then the result of Cx would be equal to 14.9k going to the right side, of course. Now, look at the lower left part. We have the all forces acting, all moment acting counterclockwise is positive. For the summation of moment C is equal to 0, and AX times 15, it is the length, plus 11.8, it is the value of the A, and positive 23.5 plus 23.5 equal to 0. Thus, AX is equal to 2.35k going to the right. And thus, AX is equal to BX. They would still get the same results. Let's look at the lower right part. It is the all forces going right is positive, and the summation of all forces H equal to 0. So QB2 minus 14.9. 14.9 is the value of your CX right above the said problem, plus 2.32 plus 2.32. It is the force. It is the forces. Is equal to Cx equals to 19.6 going to the right side. Here, by superimposing the horizontal forces of joints C and E, we obtain that negative R1 plus C1 QA1 equals to C2 QA2 equals to 0, and negative R2 plus C2 QB1 minus C2 QB2 is equal to 0. And 18 plus C2 times 45.1 minus C2 is equal to 19.6 equals to 0. That is the values. We're just substituting them all. And negative 9 plus C2, 19.6 plus C2 times 14.9 equals to 0. Rounding them up, 45 minus 45.1 C1 minus 19.6 C2 is equals to 18, and negative 19.6 C1 plus 14.9 C2 equals to 9. Proceeding then, look at the lower left part. We have C2 is equal to 45.1 C1 minus 18 over 19.6, and your another problem, C2 be equal to 9 plus 19.6 C1 over 14.9, and proceed. 45.1 C1 minus 18 over 19.6 equals to 9 plus 19.6 C1 over 14.9. Just going with the problem, 19.6 times 9 plus 19.6 C1 equals to 14.9 times 45.1 C1 negative 18. You'll be getting the result of 176.4 as it was multiplied, plus 384.16 C1 is equals to 671.99 C1 minus 268.2. Now we will have the value of C1 and C2 as 1 over 287.83 multiplied to 287.83 C1 and 444.6 for the C2. You would be getting the results of 1.5447 for the C1 and 2.6360 for C2. Now, look at the upper right part. We have the members ACC, AC, CD, CE, EC, EF, FE, FD, DF, DC, DB, and BD. We have all summation of moment for QA and also summation of moment for QB. Members and moments in actual frame M is equal to C1 MQA plus C2 MQB. Just simply substitute the C1 and C2 and the moments of the said member for MQA and MQB. And we look at this as M moment of AC equals to moment of BD, thus resulting to 1.545 as it is the value of C1, and 94.04 it is the value of AC for the MQB plus the C2 2.6636 multiplied to negative 11.8, it is the value of your BD for the MQB. It is the MQB and AC, thus resulting to 118.82k negative feet. And just keep on going. Substitute your C1, C2, and moment QA to moment QB, and you would be getting your results. For the moment CA equals to moment DB, your answer would be 83.45k negative feet. Moment CD equals to moment DC, the answer will be negative 106.88k negative feet, and so on. The answer goes right there. Now this is the actual moment distribution. Look at the upper left part, that is the actual moment distribution, and the actual reactions as a this is the answer we've come up into. This answer we've got. HA equals to HB equals to 13.48k because they are just the same lines. HC equals to HD, you'd have 4.53k force going to the left part, and force Y equals to 2.96k going up, so on and so forth. Now we will be solving for the reaction as HA is equals to negative M moment CA plus moment AC over length. Now you have for your MCA, you already have your MCA. Your MCA is 118.82 minus you have 118.82 right there. Also negative let's call this identity 83.45 plus 118.82 over 15, your length, you'll be getting 13.48k. That is your actual reaction for A and B. Next is HC equals to negative MEC plus MCE over length. You'll have again a negative identity 44.44 plus 23.5 over 15. You'd be getting 4.53. That's for C and HD. Now look at the lower part. For the right part, all forces reacting counterclockwise is positive. For the summation of moment E is equal to 0. Thus you'd be getting your result for your Fy is the length. Thus you have the length from E and F of 30 minus 44, negative 44.44 and negative 44.44 is their reaction. You would be getting Fy is equal to 2.96k, and on the next right part we have the all forces reacting counterclockwise is positive. Summation of moment C is equals to 0. So dy times the length of 30 minus 0.6, as you can see right above. Your answer will be dy is equal to 7.13k going upwards. And now we have on the lower part of the right part, the values for the EY, all forces going up, for is positive, summation of forces x equal to 0, EY plus 2.96 is equal to 0. So your EY would be equal to 2.96 going down. Okay, going down. And all forces going up is positive for all summations of forces x equal to 0. So your CY plus 7.13 equals to 0. Therefore, your CY is equal to 7.13k. Sorry, that should be CY. So, as you can look at it, this is the shear diagrams for this. On the left side is for the moment distribution method, and on the right side is the shear diagram for the portal method. As you look at it, go see these are the values we have come up with. This is the moment distribution method and the portal method. This is the shear force diagrams. And you also have the moment diagram for MDM and PM. And this is the end of my slide. Once again, I thank you and good day.